Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation using variation of parameters method using another way of solving the problem using variation of parameters method part 2. Let's get going. Problem solve y double dash plus y equal to 1 by 1 plus sin x or d square plus 1 into y equal to 1 by 1 plus sin x using variation of parameters method. Here we are given a differential equation of order 2. Given differential equation y double dash plus y equal to 1 by 1 plus sin x, consider as equation number 1, and we can write y double dash as d square y by dx square plus y equal to 1 by 1 plus sin x. Now we'll write d square y by dx square as capital D square y using differential operator d, right? Now take y common from the first two terms or the terms of LHS. Consider as equation number 2, which is in operator form. So this is the equation 1 which is in operator form. Here 1 and 2 are same equations, okay? Operator form. So f of d into y equal to some function of x, where f of d equal to d square plus 1 and r of x is 1 by 1 plus sin x. Okay, and the homogeneous equation of two is d square plus 1 into y equal to 0. Consider it as equation number 3. Now we'll find the solution of equation 3 using the auxiliary equation, and later using the solution of homogeneous equation we'll find the general solution of equation 1 and equation 2. Now coming to auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we are having f of d square plus 1, right? Let's replace differential operator d by m, so that we'll get f of m equal to m square plus 1. Now the auxiliary equation becomes m square plus 1 equal to 0. From this we'll find the roots to this equation. You can write it as m square equals to minus 1, then m equal to plus or minus square root of minus 1, right? Since square root of minus 1 is I, so we'll get plus or minus I. Therefore, m equal to plus or minus I are the roots of the auxiliary equation. So the roots are complex conjugate. We know that when two roots are complex conjugates, say m equal to a plus or minus ib, then the solution of the homogeneous equation looks like y equal to e power ax of c3 cos bx plus some constant, okay, c4 sin bx. See, I'm writing c1, c3 and c4 instead of c1 and c2 because I want c1 and c2 to appear in the last general solution. Okay, fine. Now in case of a0, we'll get e power 0 into x, which is equals to e power 0 of c3 cos bx plus c4 sin bx, right? And we know that e power 0 is 1, so we'll get 1 of c3 cos bx plus c4 sin bx, which gives us c3 cos bx plus c4 sin bx. Let's now write the solution to homogeneous equation. Just compare m plus or minus I with m plus or minus ib, then for b equal to 1 we'll get the solution of homogeneous equation. The solution to homogeneous equation is equation number 3 is y equal to C3 cos bx plus C4 sin bx. That is y equal to C3 cos x plus C4 sin x, which is solution of the homogeneous equation 3. Let y equal to, just replace the parameters or constants with functions of x, a and b. We'll get y equal to a cos x plus b sin x, be the general solution of 1 and 2, where a and b are functions of x, and if we compare the solution, homogeneous equation solution, with y equal to some C3u plus C4b, we'll have u and v. Or if you compare the general solution with y equal to some au plus bv, then we'll have u and v. Okay, we'll get u equal to cos x and v equal to sin x, right? Where u equal to cos x and v equal to sin x. Now we'll find a dash and b dash using formulae. A dash is given by minus v into r of x by uv1 minus vu1, and b dash is given by u into r of x by uv1 minus v1. If you notice, you're having uv1 minus vu1 in both the formulae, so let's begin with uv1 minus vu1, and later we'll find a dash a and b dash b, and finally we'll find the general solution by substituting a and b in y equal to a cos x plus b sin x. So let's see. Here v1 is nothing but derivative of v, and u1 is nothing but derivative of u, or we can write it as d by dx of v minus v into d by dx of u. Okay, this is equals to u is cos x of derivative of v with respect to x minus v into derivative of cos x with respect to x. This gives us cos x into derivative of sin x with respect to x is cos x minus sin x into derivative of cos x with respect to x is minus sin x. This gives us cos x into cos x is cos square x, minus into minus plus, sin x into sin x is sin square x. We can write it as sin square x plus cos square x, since we know that sin square theta plus cos square theta equal to 1, right? So we'll get 1. Therefore, uv1 minus vu1 equal to 1. We'll find a dash using the formula minus v into r of x by uv1 minus v1. So we are having r of x equals to 1 by 1 plus sin x, which is a fraction. So we'll just write the formula as minus v by uv1 minus v1 into r of x for our convenience. Okay, this is equals to minus v is sin x by uv1 minus v1 is 1 into r of x is 1 by 1 plus sin x. This gives us minus sin x by 1 plus sin x, which is our a. Therefore, a equal to minus sin x by 1 plus sin x, right? Sorry, a dash, not a. Now we will find a using a dash equals to minus sin x by 1 plus sin x. We have a dash equals to minus sin x by 1 plus sin x, right? Then a dash equals to minus sin x by 1 plus sin x. In the denominator we are having 1 plus sin x. If we replace this plus with minus, then we'll get 1 minus sin x, right? Let's multiply and divide with 1 minus sin x. Then we'll get minus sin x of 1 minus sin x by 1 plus sin x into 1 minus sin x. Right? This gives us minus sin x plus sin x into sin x sin square x by a plus b into a minus b. See, the denominator is of a plus b into a minus b form, so we can write it as 1 square minus sin square x is equals to minus sin x plus sin square x by 1 minus sin square x. We know that sin square theta plus cos square theta equal to 1. From this we'll get cos square theta equal to 1 minus sin square theta, right? So let's replace 1 minus sin square x with cos square x, and we'll get a dash equals to minus sin x plus sin square x by 1 minus sin square x can be replaced with cos square x. We'll get cos square x. Now we are having two terms in the numerator and one term in the denominator, so we'll split the total fraction into two fractions. We'll get minus sin x by cos square x plus sin square x by cos square x is equals to minus sin x by, we can write cos square x as cos x into cos x plus sin square x by cos square x is tan square x equals to minus, again we can write the first term as minus sin x by cos x into 1 by cos x plus tan square x. We can write sin x by cos x as tan x and reciprocal of cos x by secant x and tan square x as it is, right? Now a dash is nothing but dA by dx, right? Derivative of a with respect to x. Now separate the variables by taking differential dx to RHS. We'll get dA equal to minus tan x secant x plus tan square x into dx. Here the variables are separable, so we can perform integration, right? Integral dA equal to integral of minus tan x secant x plus tan square x into dx, right? Since we know that integral tan theta secant theta d theta equal to secant theta and integral secant square x d theta secant square theta d theta equal to tan theta, right? So we'll write tan square x in terms of secant just by using the identity 1 plus tan square theta equal to secant square theta. From this we'll get tan square theta equal to secant square theta minus 1, right? So let's replace tan square x with secant square x minus 1. Then the above equation becomes integral dA equal to integral of minus tan x secant x plus, just replace tan square x with secant square x minus 1 into dx, right? This gives us integral dA equal to minus integral tan x secant x dx plus integral secant square x dx minus integral 1 dx is integral dx, right? From this we'll get integral dA equal to minus integral tan x secant x is secant x plus integral secant square x is tan x minus integral dx is x plus some integral constant, say c1, which is our required a. We got a. Let's now find b dash and b. Let's find b dash using u into r of x by u v1 minus vu1. So here r of x is a fraction, so we'll write the formula as u by u v1 minus v1 into r of x for our convenience, right? This equals to u is cos x by u v1 minus vu1 is 1 into r of x is 1 by 1 plus sin x, which gives us cos x by 1 plus sin x, which is our b dash. So we got b dash. Let's now find b using b dash. Okay, we have b dash equals to cos x by 1 plus sin x. B dash is nothing but derivative of b with respect to x. Let's take the differential dx to RHS. Then we'll get db equal to cos x by 1 plus sin x into dx. Here the variables are separable. So let's perform integration. Integral db equal to integral cos x by 1 plus sin x into dx. Right? Since we know that, okay, let f of x equals to 1 plus sin x, then f dash of x is derivative of x with respect to x. Okay, derivative of a constant with respect to x is 0, plus derivative of sin x with respect to x is cos x. So f dash of x is cos x. So the integrand is of the form f dash of x by f of x. Since we know that integral f dash of x by f of x into dx equals to log mod f of x, right? So we can apply this formula here. Then we'll get integral db be equal to integral f dash of x by f of x is log mod 1 plus sin x plus integral constant say c2, or we'll get b equal to log of 1 plus sin x plus c2, right? Therefore b equal to log of 1 plus sin x plus c2. We got a and b. Let's now write the general solution using y equal to a cos x plus b sin x by substituting a and b, right? Therefore, the general solution is given by y equal to a cos x plus b sin x, then y equal to a minus secant x plus tan x minus x plus c1 into cos x plus b log of 1 plus sin x plus c2 into sin x, right? This gives us minus secant x cos x plus tan x cos x minus x cos x plus c1 cos x plus sin x log of 1 plus sin x plus c2 sin x, right? You can just write like this, or you can take cos x common from all the terms, then we'll get, or minus cos x common. Let's take minus cos x common from all the three terms. We'll get minus secant x plus tan x, minus of secant x minus tan x plus x into cos x plus c1 cos x. We can write this as it is, or we can write it as log of 1 plus sin x into sin x plus c2 sin x. Okay, or write the terms involving c1 and c2. Will get c1 cos x plus c2 sin x minus of secant x minus tan x plus x into cos x, right? Plus log of 1 plus sin x into sin x, which is the required general solution. So we have seen a problem from variation of parameters method in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.